Well, students, what do you think? We're there. We've arrived. The last new concept you're going to learn this year from this class as a requirement and in Skyward. How does it feel? You'll still have an assignment tomorrow. You'll still have a test this week. But this is it. This is the last thing that I'll show you that's a requirement. We'll have some activities available later, but congratulations on making it on this last concept. It's a concept you've seen before, I think. So kick back, relax, and we'll add a little bit of complexity to what you've seen before. But congratulations, well done, and let's get started. Volume. You guys know how to find the volume of something? Know how to find the volume of a box? If I can start, if you want to find the length of something or a one-dimension piece, it's just that length. Length. If you want to find the area of something, well, then you're multiplying two things together. Length times width. It's going to be something. Let's say inches squared. Today we're doing things with volume. So volume, you're multiplying three dimensions. So it's going to be in inches cubed. You're multiplying something by something times something. The volume, how much is going to fit inside of something, whether it's a basketball or a donations box or anything, you're multiplying the three dimensions, the length times width times height. With length, you're just looking at one direction. Area, you're looking at maybe like an X and a Y dimension. And in a volume, you're looking at, if I draw it flat out, there's an X and a Y. And then you're also looking at a Z, X, Y, Z. So X times Y times Z coordinates, or we sometimes call it length times width times height. And that's the concept for today, is knowing how to find the volume, how much can fit inside of something, how many cubes could we fit inside of something. We're not asking about squares like an area, it's how many cubes would fit inside this box. So if we made a cube of inches, this little inch cube right here, how many inches cubed could fit inside that box? And the way to find out is just to multiply those three numbers together. Today you will need a calculator. Why don't I get one as well then? So they're asking you, volunteers at a food pantry up here pack boxes. How much can fit to fill the crate? Well, they give you the volume. You find the volume of the whole box, and then find out how many of these volumes can fit in there. Would be how we would solve this one. And in fact, I think I'll just go ahead and solve it to show you what we do here. The volume of the box is length times width times height. That's the volume. So 12 times 18 times 12 is 2,592 inches cubed. That's a whole big donations box. What's the volume of this right here? Well, it's 4 times 2 times 6. What do you get? 48. So we've got 48 inches cubed. So what it's wondering is how many of those can fit inside this whole box. Or if you split this evenly into these items, how many is it going to be? Well, let's see. 2592 divided by 48, sections of the size 48. 54 boxes would fit. So that's one example of how to solve problems using volume. Now today, solving for volume, it's not just going to be rectangles. They're going to give us some crazy, wild prisms, shapes, problems, just as long as you understand this concept. Volume is the length times the width times the height in a cube. But then this is a rectangular prism. Cube, rectangular prism, prism. Then we're going to be talking about other shapes as well. And the way that the book wants us to understand as well, to find the volume of some of these prisms, you just take the base times the height. That's the other way they want to show it. Well, the base in a rectangular prism is length times width. But in some of these other things, we're going to talk about trapezoidal prisms. They're going to show us some crazy stuff. Just know that you're multiplying three dimensions. Another way to say it is we're finding the area in a prism and timesing it by how high that area item is. Let me show you some examples. To find the volume here on example 1, you'd find the volume of this part right here, this trapezoid. You can find it at the top or the bottom, it's the same one. Find the volume of that, and then just times it by how high it is. Just times it by the area of the base, and then times that by the height. Same thing down here below on this triad example. It's like it's sitting sideways. This 14 is the height. You find the shape. There it is, it's that triangle. You find the area of that triangle and then times it by the height, which is 14. Right here, this problem is going to be asking about whether the ball will fit inside. And the way to tell is they're going to find the area of the base, which is a hexagon, and then they're going to times it by the height. And on here, they're telling you the dimensions. They're going to find, well, wait, we don't know what the height is. So they're going to use this formula. But the point being, it's the base, the area of the base, the hexagon, and they show you how to find the area of a hexagon. We'll get there. Times the height. On this one right here, where you have composite, where you have two figures in one, they've split it into the two figures. Find the volume of this, the base, 18 times 18 times the height, which is 18, or length times width times height. Here, the base times the height. So there's the volume of that one, and then the volume of this triangular prism. You find the area of the triangle, 1/2 base times height. There's a triangle, and then times it by the height. So it's those three dimensions that you're multiplying by to find a volume. And then right here on a problem like this, how would you find the volume of all this? Well, if you cut it into two different shapes, how can I do this so you can see? Okay, I've got a rectangular prism there and a rectangular prism there. So it's going to be the length times width times height of this one. And I'm going to add that to the length times width times height of this one. So 30 times 10 times, what's this other direction? Oh, this other direction is 10 as well. So this one is 30 times 10 times 10, because that 10 over there is the same as 10 over here. So 3,300, that's 3,000 inches cubed. I'm going to add it to this one right here. And what's the distance here? Well, it's not 40, it's 30 across because that 10 part is already taken off. 30 times 10 times 12. So 30 times 10 times 12. You've got the 300 times 12 is 3,600 inches cubed. And then you would add those two together and you have these composite figures. Now, some of you might have cut the figure this way right here and found the volume of this box up here. You'd have to do some subtraction, the 30 minus the 12 to find the height there. Length times width times height, and then add it to this, figure length times width times height. Either way, you're still going to get the same answer of 6,600 inches cubed. So just kind of showing you the different concepts you'll be learning today. Taking the area of something and then timesing it by the height. Composite figures, and sometimes working backwards if they give you some of the dimensions but not some of the other ones. There's another one I wanted to show you if they have one, where there's the inside. Maybe that's on tomorrow's assignment. Oh, number 14. On 14, this glass bead has the shape of a prism because you'll see something like this in the days ahead. What's the volume of the glass that forms the bead? So what they're doing is they're saying find the volume of this entire item, find the volume of everything, and then you're going to subtract off the volume of what's inside because we're not going to count that space in there. So when you solve this one, find the length times width times height of this whole entire space, including that empty space, and then subtract off the volume of this whole area. 2 centimeters times 2 centimeters, that's 4 times 5 centimeters, that's 20. So whenever you find out what it is, the entire area minus the 20 centimeters cubed, and you'll have the part inside. This one is so complicated, higher order, I don't know if I'd spend too much time on it. Okay, and that's the work of today. Some of this stuff, they're giving you the information as they go. We haven't talked about the area of a trapezoid, have we? So they give you the area of a trapezoid. They tell you to find the volume here, find the area of the top, and here's what it is. Area of the trapezoid. And then times that area of that trapezoid times the height. Now, if I've just lost you there, just imagine this was a square prism. Square prism. You find the area of the top and then times it by the height. It's just on this one, the top is a trapezoid. Find the area of the trapezoid, just like you're the square, and then times about how high it is, by how high it is to get here. Just know that this area of a trapezoid, I don't know that you have to necessarily memorize it, but it's good to see it and know where to find it in the book when it comes time to do tomorrow's assignment and test. Just area of a trapezoid, it's basically two triangles. If you can see me kind of, here's a trapezoid right about here. If you can see a trapezoid, if you cut it in half right there, we're basically talking about the area of two triangles. And so how do they find this? What's this big old long, ugly, awful equation? Well, it's really just saying 1/2 base times height, and there's one base, and then 1/2 base times height, that base. Then you've got these two triangles, and you add them together. That's basically the equation when it's morphed into that. So here we go. What's the volume of a triangular prism? You find the area of the base, and then times it by the height. Oh, here we go, the base times height. So 1/2 base times height, 1/2 of base, 8 times 6. That's the triangle, and then times it by the height, which is 14. So whatever this 8 times 6 is, whatever this triangle is, let's see, that's 48. Now let's do half of 8. Half of 8 is 4, so 4 times 6 is 24. So the volume is going to be this 24, this area of the triangle, times 14 times d, or 14 times high. And I have no idea what 24 times 14 is, but my calculator knows. $336. So the volume is 336. So I've done some of the examples. I've kind of shied away from this one because they're just asking you if the basketball fits inside. And they go through so many convoluted steps to figure out if it fits inside that I'm not 100% comfortable with it. Just know that when you're trying to find the area of a hexagon, it's just 6 of the triangles. 6 of the 1/2 base times heights. And then they'll give you the numbers you need to have. So 6 times the equation, and then fill in the numbers to get the number. Let's see if I can find one of these on the assignment. One of these really hard ones on the assignment that you can work on. Volume of a toolbox. You can see that that's the one shape with the other shape. Well, here we go. A tunnel for the amusement park has a shape of a regular hexagonal prism with dimensions shown. If there's the whole volume, can 2 cars pass through the tunnel at the same time? So I'm wondering, here's the 2, so here's the 8-meter car, and 2 of them, 8-meter car, connected by a 3-meter pass through. So what they're saying is the height of this, 8 plus 3 plus 8, that's 19. They're wondering, is the height 19? Well, the way to do that, the volume is the base times the height, like they're showing you, or it's the volume is the area of the hexagon times the height. So the volume is, well, the hexagon, that's just 6 of the triangles times the height. And the triangles, let's see, the height is 7. If you think of that triangle, height is 7 times 8.1 in half. So 1/2 of 7 times 8.1. The volume being 6 of these triangles times the height. Well, here's the volume right here. So 3572.1 is 6 of the triangles, 1/2 times 7 times 8.1, times the height, the volume, the hexagons times the height, and they're wondering how this 19 is going to compare. So when we put all that into our calculator, 3572.1 equals, I have no idea what 6 times 1/2 times 7 times 8.1 is. But you do the parentheses first, so 1/2 times 7 times 8.1, 28.35, and times that by 6. So this is, volume is the 170.1 times the height. Now to get the height by itself, this is that part about solving the equation where you divide it off. So 3572.1 divided by 170.1, 21. So the height over here, the height is 21. Well, how does that compare to the 19? Would that 19 fit in the 21? Yes, it would. That's just one example where they give you all these steps to try to find one of the missing pieces. Same thing up here, they've given you the height right here at 6.1 on this hexagon. So just know when you're finding it, it's the area of the 6 triangles times the height. So it's 6 of the 1/2 of the base, 7 times 6.1, times the height, which is 14. And I've written here, but you can check against down here and find out if you get the right answer with the answer key that I'll provide. Try a few of these. Just know that in finding volume, the main thing to know today is that when you're finding the volume of something, it's simply finding the 3 dimensions. I've talked about length, width, and height. That right there, that's because length and width is of a square. So that works very well on a rectangular prism. If it's not a rectangular prism, it's the base. It's whatever the area is, area of the base. So you find that and then times it by how many times that's repeated, how many height or how many depths it is. And sometimes you have to find 2 of those figures. Give a couple of these a shot. See if you understand the concept. We'll do some more practice on it tomorrow before the review and test here at the end of the week. Thanks for watching. Go through it and hope this helps. Let me know if you have any questions on this last concept for this chapter today. Well done.